Okay, good afternoon, everybody. I hope you're having a productive and enjoyable re:Invent. Congratulations on making it to day 4. You're almost there. The next hour or so, we're going to be talking about authorization within the applications that you build. We're going to be hearing from 2 AWS customers who will talk us through how they've used AWS technology to authorize users within their applications. I am Julian Lovelock. I'm the product manager for the CEDAR policy language and for the verified permission service. And I'll be joined today by Con, Scott, and Anna from Grosvenor Engineering Group and Fidelity Information Services. And I'll let them introduce themselves as they take the stage. Oops. We're going to start by explaining what is policy-based authorization and why do we do it. We will introduce the CEDAR policy language and Amazon verified permissions and position them. And then we'll dive into 2 case studies, one with Fidelity Information Services and one with Grosvenor Engineering Group. And as always, we'll wrap up with some conclusions and next steps. So what's the challenge we're trying to solve? Well, most organizations have hundreds, maybe even thousands of applications across that organization. And these applications give customers and employees and partners access to enterprise resources. Those resources can be data, they can be functionality, they can even be physical spaces. And typically, each application is managing its own permissions and making its own authorization decisions. And this causes some challenges. From an audit perspective, it generates a cost problem because it becomes very costly to audit what access customers or users more generally have to resources across the organization. And if you're in a regulated environment, such as financial services, that's expensive to go through the process with your auditors of explaining who has access to what. There's a risk element because each application is implementing its own permission system. Each development team is in many ways reinventing the wheel as to how to implement user permissions within that application. And it generates friction because each new application that you build, you have to re-implement your permission system. It's not a new problem. We've seen this problem, and indeed we've solved this problem already for authentication. Cast your mind back far enough and you'll remember a time when each application managed its own users and did its own authentication. And that generated similar problems. And we solved them by centralizing the authentication process through what we often refer to as an identity provider. And part of our ability to do that came from the use of standardized protocols like OIDC and SAML that enables the application to communicate with the identity provider. So what we are doing now is taking a similar approach for authorization. We're centralizing the authorization process into what we might describe as a central policy and decision engine. And that policy and decision engine or authorization service stores a set of policies that describe what users are permitted to do within the applications. And then each time a user uses an application and attempts to do something, we call the authorization service, which checks the policies to determine whether this is permitted or not. These applications also need to be able to manage permissions themselves. Permissions change as users use the application. They create new roles, they assign permissions, they grant access. So the applications also need a policy management API to be able to dynamically change permissions as the users use the application. And all of this requires a policy language. We have to have a language in which we articulate the rules of who is permitted to do what. And this is where CEDAR comes in. CEDAR is a policy language that was invented by AWS, and about 1.5 years ago, we made it open source, enabling anyone, regardless of whether they use verified permissions or not, to take advantage of the CEDAR policy language to write policies that describe who is permitted to do what within one or more applications. And we open sourced not just the language specification, but also a decision engine that can evaluate policies and reach a decision. What do those policies look like? Well, one of our main criteria when we designed this language was readability. We want somebody who's not a developer to be able to look at this policy and understand what's going on. So this policy hopefully is relatively simple. It acknowledges a role called doctor, and it says that a principal, aka a user, who's in that role is permitted to take a couple of actions, refer patients and update patient records on resources of type patient. But there's a caveat in there, there's a condition. The condition is that the patient, or rather the doctor, needs to be the primary care doctor of the patient. You can see what we've done here is combine both RBAC, role-based access control, and ABAC, attribute-based access control, into a single, relatively easy to read policy statement. So how does this then play out in an application? What are the different moving parts of an application to be able to take advantage of this? Well, if we take Fidelity's application Profit, which Scott and Anna will talk about shortly, as the example, we see there are really three components. So the challenge is we have a user, said user is attempting to take an action, edit, on a resource which is a workspace. The first thing we need to do within the application is collect information about that user. Sorry, to collect information about that resource. So there's a resource database, we get the attributes pertinent to the resource. Then similarly, we need to collect information about the user. We then take that information and we provide it to Amazon Verified Permissions, and we make the call that says, okay, I have a user, said user is in these groups, they have these attribute values, they're trying to access this workspace, said workspace has these attribute values, is this permitted, yes or no? Verified Permissions will come back with a decision, and then it's up to the application to enforce that decision. So we've introduced a few pieces of terminology in here. We have at the top what we often refer to as a policy information point. This is where we're gathering information that's pertinent to the application of the policy. We have a policy decision point where you're making the decision about whether or not you're allowed to make that access. And then you have a policy enforcement point which enforces that decision. Those with familiarity with XACML will recognize these terms. So that's enough from me. I'd like to introduce Scott to the stage. He will introduce the Profit application, and then Anna will give us a demonstration.
Thank you, Julian, and good afternoon, everyone. My name is Scott Glassford, and I'm joined here by Anna, and she'll be taking you through a live demo a little bit later. And first, a little bit about myself so you know who you're listening to. I am an actuary with 15 years of experience in the insurance industry, and I've had the privilege of working at the intersection of financial modeling, technology, and regulatory reporting. At FIS, I lead efforts in North America to make sure that our regulatory libraries are up to code and making sure that they're following trends in the shifting regulatory environment of insurance. And also, a part of my role is making sure that we have a lot of client feedback coming back into our product. So some of it is client management and client relationship building. You may not be familiar with FIS. Let me introduce you to FIS just a little bit. We are a financial service software solution organization, and we have solutions for all parts of the financial services lifecycle, okay? And to give you a sense of scale of how big FIS actually is, we have 70,000 employees worldwide, and just alone last year, we had $50 trillion worth of payments processed on FIS solutions. I'm not here to talk about banking. I'm here to talk about how we've used Amazon Verified Permissions in our solutions, and that is where FIS Profit comes into play. So what is FIS Profit? It is an actuarial modeling platform, and it is a very successful platform. We have 80% of the top 50 insurers around the world using FIS Profit in some capacity. We have a large footprint. We have 10,000 users worldwide in 70 different countries. And Profit's been around for 35 years. And the reason why it's been so successful is that it's extremely flexible and it's holding up to the regulatory demands of today by being able to scale calculations in a very efficient way. Let me take you through how some of our users use Profit. One of the major reasons why people have Profit in their organizations is to satisfy regulatory needs. As a part of my job over the past few years, I've helped us develop a solution for US regulatory reporting called LDTI. We also have a solution for IFRS 17, which handles financial reporting around the globe. We also provide capital reporting across the globe. This includes Solvency II in Europe, RBC in the US, Bermudan capital, among others. Another attractive feature about Profit is the ability for our users to to code up their own models. And what this provides our clients the opportunity to do is develop their own IP effectively and test out new types of contracts and new types of contract features when they do their pricing exercises. And another way that our users use Profit is to manage capital and do asset liability management. And these frameworks just allow organizations to come up with reinsurance strategies and asset strategies that help them position themselves in capital markets, and it allows their management to make decisions to make them profitable. Oh, hold on. Sorry, I was on the wrong slide there. So it's speeding through. But anyway, yeah, we'll get into. So because Profit's been around for 35 years, the question is how do we last for another 35 more? Well, what we're doing with Profit is we're moving it to the cloud, and we are offering a SaaS solution to our clients built on the back of AWS. And two of the new modules that we released in the last year are called Risk Production Manager and Climate Risk Financial Modeler. So to talk about Risk Production Manager will revolutionize the way actuaries access cloud resources. No longer will actuaries need IT intervention or a dedicated environment for them to scale up their calculation grids. Users are going to be able to develop models and workspaces on their local machines, upload them to the cloud, and then grab the cloud resources that they need to speed up their model runs. In some instances, we've seen models that take a day or longer to complete be reduced to a runtime of less than an hour, simply because they had access to these cloud computing resources. And something that FIS is finding valuable with SaaS and the service it's providing to our clients is that we're able to deploy tools quickly and efficiently without disrupting insurance operations. And we're also able to respond to emerging risks like climate risk in a quick, efficient manner. So let me talk to you about what Climate Risk Financial Modeler does. Climate Risk Financial Modeler allows insurers to quantify risks to physical assets around the globe. And what it does is it models weather patterns and greenhouse gas emission scenarios. And when you do that, what you're able to bring together is the ability to quantify potential losses around the globe. And within this platform, what you're able to see here are really cool dashboards, honestly. You have pictures of the globe and circles that quantify or visualize for you like where your exposures exist. And so when you look at that dashboard, it's easy to see that you might have some pretty big exposure in the UK there with that big green dot, and that could be due to wind, hail, or whatever. So with that, when actuaries and risk managers look at these reports and share them, it's a really quick and easy way to understand results and share results across the organization. Now, this is how we've been advancing Profit. Another way that we've advanced Profit is incorporated Amazon Verified Permissions. And what Amazon Verified Permissions allows actuaries to do is comply with regulations. Again, a core tenet of FIS Profit is regulation compliance. And so the regulation I'd like to talk to you today about is Sarbanes-Oxley, or SOX. And SOX was created as a US law to ensure the integrity of financial reporting, which is consumed by public traders and regulatory bodies alike. And so what SOX requires is the integrity of financial reports to be kept, and that creates some challenges for operations because there have to be rules and regulations around how people interact with models and data. So first, under Sarbanes-Oxley, everything as part of the financial process has to be auditable meaning you have to be able to track who accessed what and when data was created. Another challenge for actuaries, traditionally, without a SaaS platform, multiple systems that feed the financial reporting system are all over the place. And so having some sort of authentication system for all these different systems is a bit of a challenge to comply with Sarbanes-Oxley. Another thing that is a challenge for actuaries is you have large actuarial teams creating parts of your financial reporting in different parts of your organization, and they need to be aggregated. And so when you're dealing with different teams, it's nice to have a central location for your authentication. And finally, this is more of a traditional user-based role permission thing with the segregation of duties. With segregation of duties, Sarbanes-Oxley requires that modelers are the people who run the models, no one else. Model approvers are the ones who approve the models. They can review the models, but they can't run them. And then you have auditors, the people who are reviewing the results, but they shouldn't be touching the models in any way. And so to have an authentication framework that makes this easier is extremely attractive for actuaries. And so now we're going to talk about how we've implemented an FIS Profit. So the major change here is the ability to tag our workspaces with separate attributes. For instance, a workspace could have 3 different types of attributes. It could have limitless attributes, but a good example is, okay, this model is an Italian model. This model is for Q2 reporting, and this model is for life insurance contracts only. And when you combine that with traditional user roles like modeler, auditor, and reviewer, you have a really robust authentication framework that allows you to really key in and dial in who has access to what. And this does help quite a bit with Sarbanes-Oxley compliance. And that's all that I'd like to say about Profit. Anna's going to talk about how this was implemented in Profit. Take it away, Anna.
Thank you, Scott.
Of course.
Let me first switch to my screen. There we go. So hi everyone, my name is Ana Košutić and I'm a software engineer at FIS. I've been working with the AWS team on implementing permissions framework and integrating Amazon verified permissions into our Profit SaaS platform. Today I'll walk you through a live demo on a real application with focus on permissions management. So let's dive in and see how it all comes together. First, I will log in as a standard Profit SaaS user, which is usually an actuary, to demonstrate how it functions from their perspective. Let's open Production Manager application, and we will open Workspaces page. But first, again, what is a workspace? A workspace is a fundamental concept of a Profit SaaS platform. It provides the environment where users can perform calculations, do model runs, and it consists of various metadata which together help perform those calculations and produce that final result which is needed for actuarial analysis. Since Workspace is such a big part of our platform, we chose it to be the main object to demonstrate how permissions work. On the screen you can see we have 2 objects. We have Global Workspace and European Workspace. If we open Global Workspace, you can see structures, run settings, products, local table sets, and those are all metadata that I've mentioned. Now, an actuary would want to try to edit some metadata before running some calculations, or edit a name, edit a description, basically to perform edit action on workspace object. So let's see how editing works on workspaces. And for the simplicity of the demo, we'll just edit a description and try to save it. And we're getting workspace has been saved, which is expected successful response. But let's try European Workspace now. Even if it's called European Workspace, you can see by the description that this one can be used in Italy only, which suggests that there might be some additional restrictions added to it that we as a standard user are currently not aware of. But let's try to edit the description and say this one can be used in Italy and Spain also. Now we're getting user is not authorized to update this workspace. And now I want to switch completely to a new browser and log in as administrator user to showcase some additional capabilities as admin user, but mainly to explain why this happened to an actuary user, that actuary was able to perform edit on one workspace and not on another one. Let's switch to a light theme just so we can have that clear visual difference between these 2 browsers. As admin users, we have one additional application available, and that is Platform Administrator. It offers users page, attributes page, roles page, And let's take a look at the list of roles first. We have workspace editor role and workspace administrator role. Workspace editor role gives us permissions to view and modify workspace objects, but without the ability to create them. And we will focus on production manager application for the demo. On the left side, you can see a list of available objects within the application, such as workspaces, table sets, jobs. And when I say objects, it is the same as resource. And on the top, you can see a list of available actions that you can choose to allow to be performed on those objects. And you can see for this role, we chose to allow all actions except create for workspaces objects only. On the other side, workspace administrator role gives us full access to manage and perform all actions on workspaces. And you can see we selected all actions, again, only for workspaces objects only. I want to explain what is happening in the background when you are using roles. When you create a new role, you're actually creating a new CDR policy and saving it in Amazon verified permissions. In our case here, we have 2 roles, and with them we created 2 separate CDR policies and saved them in AVP. And I want to quickly show you that. So let's go to AWS console. We opened Amazon verified permissions. Here is a list of available policy stores. Each policy store is dedicated only to one tenant at a time. So the second one is only dedicated for the tenant that we are using for this demo. And here we have a list of policies. So as I mentioned, we have 2 policies. First one dedicated to workspace editor role. And second one is dedicated to workspace admin role. Julian will explain these policies more in details after me. So let's go back to roles. Roles itself are giving the ability to assign permissions to a user at a coarse grain level. However, we want to be able to assign more granular permissions, and that is why here we have attributes page. This is where you can define custom attributes and enforce that attribute-based access control. You can group similar attributes into a group, and that is why here we have country. And country is attribute group that contains attributes that define specific countries. With attributes, you can tag both users and objects. And here we have attributes Italy, Spain, Serbia, Hungary, USA. But you can notice that we have all at the beginning. And all is a special attribute that represents every single attribute within the group. And every group has it. In our case here, attribute all represents every single country. This is very useful for admin users in some special cases when they want to assign every single attribute to an object or a user, and instead of listing every single one, you can have sometimes a lot of them. They can just put all and it will grant permissions for every attribute. We have 2 users. We have admin users, which is user that we are currently viewing, and we have actuary user, which is user from the first browser. We can see that admin user is assigned with workspace administrator role, which is where we defined actions that can be performed on objects, and is tagged with attribute all, which again represents every single country. This means that admin user is allowed to perform all actions defined within workspace administrator role on workspaces that are tagged with any country. On the other side, actuary user is assigned with workspace editor role and is additionally tagged only with one attribute Spain. This means that actuary user is allowed to perform actions defined within workspace editor role on workspaces that are tagged with Spain. And let me explain that those workspaces can be tagged with multiple attributes, but one of them has to be Spain in order for actuary to be allowed to perform actions that are defined within that role. I want to open production manager application again now, but from admin perspective, because as admin users, we have the ability to see a list of attributes that are assigned to an object. And let's take a look at global workspace first. We can see that the global workspace is tagged with attribute all, which again represents every single country. And that is basically the reason why actuary was able to perform edit on this global workspace. Let's take a look at other workspace, European workspace. This European workspace is tagged with Italy. And again, as a reminder, our actuary user is tagged with Spain. And Italy and Spain do not match. So this is important part to understand. Intersection between list of attributes assigned to an object and list of attributes assigned to a user is what allows or denies a user to perform actions that are defined within the role. In this case, we have Italy on object side, Spain on the user side. Italy and Spain do not match, so we don't have that intersection between lists of attributes. So actual user was getting a deny for performing edits on this European workspace. But as admin user, we have the ability to manipulate with attributes. So let's add another one, attribute Spain. So now we can have Spain on both sides, on object side and user side. And now actually should be able to perform that edit on this European workspace. I want to go back to the first browser where actual user is logged in to try that out and see if this change reflected correctly. And now actual is able to perform edits on this European workspace. Let's try to edit the description and say this one can now be used in Italy and Spain also. Now we're getting workspace has been saved, which is expected successful response. And this really demonstrated how our system employs that rollback access control and attribute-based access control. And as a developer who worked on this integration between Amazon Verified Permissions and Profit SaaS platform, I want to share a few reasons behind this choice. Beyond providing security, obviously, we wanted to have access control that is easy to manage and track. And AVP, with its CEDAR policy language, allows us to define permissions externally and manage all these policies at one centralized location. It provides a clear audit trail by logging every action that is made, who made it, when was it made, and store all these records securely for you to review whenever you want. Big advantage is also easy support for multi-tenancy because, as you saw already, we have one dedicated policy store for each tenant, which really keeps our client data separated. And integration with AVP is straightforward. We had one authorization API call that returns a clear allow or deny response depending if the user is allowed or denied to perform an action on an object. In our demo here, it was authorization call for action edit on object workspace. And all of this that I've mentioned not only simplified permissions management, but enhanced flexibility, security, making AVP really crucial asset to our application. So thank you for letting me share this today during event. I'll be around if you have any questions or you want to chat, and I'll hand over to Julian.
Thanks, Anna. So just come back to the slides now. I want to drill down quickly on the policies and just show you how the policy that Anna created actually does its work. So we're able to, yeah, perfect. So she showed you briefly in verified permissions a quick view of the policy. This is it expanded out. And I want to highlight a couple of areas of the policies just so you understand it. So you can see in the scope of the policy, we call out the role, in this case, workspace editor. And if you remember when Anna was in the admin console, she actually created a role called workspace editor for which this policy applies. And she selected the different actions that a workspace editor is permitted to do, to read, to download, to edit, but not to create. And you can see that's represented within the scope of the policy as the specific actions there. So were Anna to go check the create box and save that, what would happen is this policy would then get updated to include create as a permitted action for this role. But then there's also the question of the intersection of the attributes. So at the base of the policy, you can see a set of attribute-based conditions. And if we go through them, we can see that if the user is tagged as all for countries, then that's okay, condition is met. Or if the workspace is tagged as all, again, condition is met. But if neither is the case, then the attributes of the user need to map to the attributes of the workspace. And that's what Anna did through her demo. She added Spain to an attribute of the workspace, thereby enabling the user who was tagged for Spain to be able to edit that policy, to be able to edit that workspace. So you can see here how the policy, as I said, is applying a combination of role-based access control and attribute-based access control to narrow down the scope of permissions appropriately. So with that said, I'm going to hand over to Con, and Con's going to introduce Grosvenor Engineering and how they used verified permissions.
Thank you, Julian. Hi, everyone. Good to be here. My name is Con Salikis. I'm the Chief Technology Officer for Grosvenor Engineering Group. And I'm very excited for the opportunity to tell our story here in Vegas in this year's reInvent. So Grosvenor Engineering Group is an Australian company based in Sydney. And what we do is we look after building technical systems, such as HVAC, fire and electrical systems all over Australia and New Zealand. So this would be all the high-rise buildings that you may see around the Opera House, all the way out in the desert. And what we do is our mission is to deliver sustainable outcomes for property owners by using a proactive maintenance approach. So for us to achieve that, we realized early in our journey that we needed to build our own enterprise resource planning system that would incorporate maintenance management capabilities. And as early as the late 90s, we came up with ARMS, our asset resource management system, that so far has allowed us to resolve more than 17 million actionable insights across over 1.6 million assets. And to unpack the actionable insights concept, really, they come from the maintenance plans that we have prescriptively designed and evolved over the years, along with insights that we extract out of the building systems to promote them back to the technicians. So when a technician goes on site, they can understand what needs to be done during the maintenance or the reactive works. So you can think of ARMS as, taking your car to the mechanic and looking at all the things that need to happen to make your car run effectively and have a longer life. So as you can imagine, with all those complicated assets and complicated operations, there was a strong need for robust authorization as we set out to modernize our systems. And really looking at the future state authorization, I guess it's good to discuss the evolution of ARMS. And in its current state, or up until now, ARMS was really an internal tool with two versions. One was the back office version, where we had our traditional ERP capabilities, allowing us to coordinate resources to do their work on site. And on the other side, we had field services capabilities that would allow our technicians to conduct their work whilst on site. And all that, going through that circular workflow of validation would allow us to contextualize that information and put more financial context for our customers, where we give them portals to understand how to make CapEx decisions, understand maintenance and asset performance, and understand their buildings in general in more depth. Now, in the future state of ARMS, and really that's driven from our core business, being Grosvenor, we have had a surge of subcontractors who are effectively our partners, contributing to the service delivery that we do in our portfolio. Our next step is to enhance that multi-tenancy capability and allow ARMS to be an external tool so we can enhance our service delivery in more detail. And with that detail, what comes with it is an enhanced user experience for our customers with more service management capabilities, deeper asset performance insights, and raw machine data from their building systems. So to achieve all that, and remember, we're talking about moving from a legacy monolithic system to a cloud-based web application that is hosted on AWS, we had to understand what components need to be redesigned to decouple, and of course authorization was a key component. So because we had different personas that are linked to different layers of our business logic and data hierarchy, separation was important so we could curate those views for each user. So as an example, as I'm showing you here, you might have a persona who is a technician in the field, might need access to a specific building or even a specific asset to achieve the outcome that is required of them. But to understand that a bit more, what I'm going to do is I'm going to take you through the ARMS application, and I'm going to take you through an example. And we will review that real-life challenge, and then after that, I will run you through it and work backwards to understand all the components that had to be put together to achieve that outcome. So to start, here you can see the back office version of ARMS, and what I'm going to do is I'm going to allocate myself as a technician to a job. So effectively, this is a work order. And if I was to allocate myself to that job and went to the project configuration of that job, we can see that there are different attributes that define the business logic of the workflow of that specific persona. And now if I was to mimic that technician out in the field and go to the MyAmps application that you've seen here, if I go to the workflow and you go to the additional work section, you can see that there's a quote amount of $1,800, similar to the project configuration that were before. So that sets a limit, a budget, for technicians to do certain jobs on site without approval. So selecting an asset and putting a quote title and a test reason for work. I'm then presented with different options to put certain cost components of that quote. So for a rate of 95, if I was to put 20 hours, you can see that the calculated total is $1,900, therefore exceeding the quote budget that was set in those project parameters before, which means that a technician cannot access the job on site and requires further approval from the client. So that's the workflow. That's how we wanted to implement all this. And now if we go back and look at the authorization challenge, we really zoomed out and tried to understand what is it that we really need, what are the requirements, and we distilled them in 3 key challenges. The first challenge is that we wanted something that was pre-built. We wanted to remove the heavy lifting of maintaining a bespoke system and abstract the security overhead that comes with that. Also, we wanted something that would be future-proof and feature-rich because we wanted to avoid building a customized solution that may bring roadblocks in a future roadmap. Because it's hard really to predict how your product is going to evolve in the future and whether you need to take steps backwards. Now, the second challenge was about flexibility. The legacy application was traditionally designed around role-based access controls philosophy, but we wanted to incorporate attribute-based access controls into the application, similar to the use case I showed you with the quick quotes attributes. But also, we wanted to aggregate policies from multiple data stores. Because the application had proliferated in different systems, integrating it back into one, we wanted to find information that was stored in SQL databases, graph databases, or even object stores that we knew were going to drive business decisions through our authorization logic. So we wanted to have a separate policy repository to drive those decisions. Now, the third challenge was, of course, scale. So we wanted something that would be serverless without having the need to manage dedicated instances, would have high performance, and hopefully reduce the challenges that come with horizontal scaling, and, of course, be cost efficient. And we're at that point where we're evaluating 2 different avenues. We were contemplating different open source solutions that are out there, or the other solution that we're looking at was to incorporate a bespoke service that would be within our application's code. And it was at that point that verified permissions reached general availability. And what we did is we put together some test policies that we knew were part of the future brief of the application, tested them in a policy playground, and then designed policy templates and integrated them into our architecture through a proof of concept. So the result was high performance and a linear consumption-based model that would fit our budget appetite. So what I want to do here quickly now is I wanted to take you through 2 different architectural flows of how our application works, to use case a few different approaches that we took to integrate it with a legacy application. The first one is your stock standard API calls approach using the AWS stack. However, what we've done is we wanted to run the legacy application concurrently with the new. So we wanted to maintain the same attributes across both sides until we transitioned. So here in the first step, you see the front end making a login request to Amazon Cognito, which in turn then launches a pre-authorization trigger. And that Lambda function collects custom attributes from or looks for new attributes that can be injected as custom attributes into Cognito's user pool. Once those are injected in Cognito, it issues the authorization tokens back to the front end. And the front end with any API call would send those authorization headers to the API gateway. The API gateway then forwards the tokens into a custom authorizer. The custom authorizer validates the tokens and then decodes the JWTs to retrieve all the custom attributes. The custom attributes then are used as keys in verified permissions to look out for any policies that match the request. And then if AVP responds with an allow response, the API gateway is prompted to forward the request to the appropriate Lambda service. So in the second flow, I wanted to show you how we creatively utilize the verified permissions to drive UI behavior. Because we have different users that may require different permissions, we wanted to have a flexible user interface that could change for each user. So here what I'm showing you is, as before, at application launch and through other set intervals or triggers during the runtime of the application, the front end makes a login request incognito, which in turn then issues the tokens back to the front end. And then the front end will reach out to a dedicated permissions route. The custom authorizer will just validate the request. It won't decode it, but it will forward the token to the Lambda service, which will in turn decode the attributes and look up for policies that are UI specific. So we have naming conventions and categories based on actions from the policy to retain all the UI component policies for that user or groups that he or she may belong to be retained as an array back to the front end, where they are stored into the WebAssembly store and change the UI behavior. So just to wrap up on those two flows, I wanted to show you what those policies may look like. So on the right, you can see the JSON Web Token attribute samples. So you have some custom attributes that are used as key value pairs to look up those policies through AVP. On the top left, you can see a UI-specific policy. So effectively here, you have the principal being the user or a group. You have an action that classifies the type of the policy. And then on the resources, you have a UI component policy name that is matched on the same naming convention as the UI components in the front end. Now, on the bottom left, you can see an attribute-based access controls policy. And this is specific to the quick quote amount that challenge that I showed you before. So you can see that the context is the quick quote amount that is equal or less than $1,000. And then the resource is the project ID that drove that decision. So that's a classifier to understand what entity it refers to. Now, interestingly here, you can see that the project ID is not directly associated to the JW2 attributes. So that's something that you might want to think about when you design your application. So next, what I wanted to do is I wanted to walk you through ARMS again and show you how all these components apply through AVP. I'm showing you a configuration that is quite esoteric. This is to configure the fixed groups that exist within the application. And I've removed all the project components that are UI specific. So because I've done that, if I was to go to the project dropdown in the navigation menu, you can see that the project option is not available. And if I was to go to the recent section of the application and try to access a specific project, I get an unauthorized response. So if we were to go to AVP and look for that policy for that particular user, we can see that there's no policy found, hence why that was why the application didn't return anything. But if I was to include all these attributes and save them, it will obviously make the changes in AVP. I'll refresh the application just to validate that they've been applied. Great, we can see that they're there. So now if I go to the dropdown again, you can see that the project element is there. And if I would try to access a particular project, I can now go into the project and go into the project configuration tab as before, where we have the quick quote amount set at $1,800. So if we were to go back to AVP and have a look for that UI component policy first, for that user, being myself, we can see that the UI component policy now exists, which is what drove that change for me to access that area in the application. But if I wanted to now check the attribute-based access controls for quick quotes, we can see that that same policy schema is applied here for $1,800 or less for that project ID. So let's say that a customer gave us approval to have a budget of $3,000 instead for that project. And if I was to change that here and save it, we can go back to AVP and check that policy. We can see that that same policy has now been updated to have a different value of $3,000 equal or less for the quick amount context. So if I was to go back to the MyArms application, go to the additional work section where it retrieves the policy, we can now see that the $3,000 reflect the policy. And if I was to go and select an asset, go next, the same admin, put test and test. I'm then again presented with those cost elements. I'll put again $20 for a rate of 95. We can now see that we don't exceed the budget. And if we were to go next, we can see that we can action the quote on site. So we collect an email for the customer, then a name, and then a signature. And then we can successfully submit to action. So that will create a new job for the technician to do it on the spot without approval. So happy days. So alongside all that implementation with the ERP system, another challenge that we are working on, which is currently coming out, is the incorporation of the energy management system that was designed in-house with our ERP system. And what we do with our EMS is that we collect time series data from different technical assets in buildings. Imagine energy meters or compressors or other technical assets. And all these time series data go into a data lake, which is then mapped through an ontology in a graph database. So we do the correlations between what is stored in the data lake against a graph database. But for us, the challenge here was that you might have different personas that might require different access to that information. And you might have a sustainability officer, for instance, like I'm showing you here, or a facility manager that require access to the entire building and all the assets that are related to it. Or you might have a tenant that is on the 21st floor, for example, that requires access to only a specific subset of those assets. And the way we went to restrict that, because we wanted to do it natively from what the token requester is we relied on the context of the user ID. And then through the context of the user ID, we forwarded the request to verified permissions. And instead of relying on an allow or deny response from AVP, we actually look at the name of the policy that allowed the request. And based on the naming convention of that policy, we then look up all the inferred entities in the graph database to find all the associated entities. From there, we construct a limiting statement. I mean, it's a little bit more complicated than that, but we find what assets relate to that user and construct a response back to the API. So to understand that a bit more, I can just show you the architecture. So effectively, the Lambda authorizer forwards the context to AVP. We get the name of the policy that allowed the request. Through that, we forward the policy name, and there's naming conventions that are fixed in the graph database. And then from there, we find all the associated entities and look into the data lake to find all the associated data. From there, we forward back the response to the API gateway, and from then onwards, it's just business as usual. So just to wrap up, I guess I wanted to close with 3 key lessons that I learned through our journey at the Grosvenor Engineering Group, doing all this. The first lesson is don't try to invent a CEDA. Incorporating authorization policy into your code can add complexity and may restrict you from future changes in your roadmap. The second one is to learn CEDA. CEDA can come with a steep learning curve, but you can, as you separate your authorization logic from your applications code, it can give you a lot of traction and can pay off in the long run. The third lesson is that AVP can be more than just permissions. As I showed you in the previous use cases, you can creatively utilize verified permissions to enrich your application's behavior and features. So thank you, everyone. That's it from us. Back to you, Julian.
Thanks, John. I want to pull out a couple of themes that we've seen through both of these presentations. One is to take an existing application and move it forward to a new generation version of that application and use verified permissions in that new generation to implement a far more fine-grained and secure authorization model. In both cases, the way that's been done is to take the existing coarse-grained role-based model and augment it with attribute-based conditions, so combining RBAC and ABAC. It's also interesting that, particularly in the case of the Grosvenor example, you can see that authorization rules are being used for actual business rules. In Con's case, he showed how a CEDA policy was defining the level of payment or the level of value of a particular quote. That's not a security use case, that's a business rules use case. In both cases, the application is modifying the policies. So as the administrator uses the application to change permissions, so those permissions are reflected in updates to the policies. And because AVP is audit logging all changes to policies, you have an audit trail of the provenance of your policies. You understand where those policies came from, when they were created, who created them. I want to wrap up just by talking quickly about Cognito. So we've talked a lot in this presentation about authorization. And as we've seen from Anna and Con sessions, authorization is dependent on authentication. We've want to basically highlight some new release in the Cognito product and some features that come with that I think create a really strong better together story with verified permissions. So I'm going to highlight a new SKU within the Cognito pricing model called the Essentials SKU. Within the Essentials SKU, you get support for passwordless authentication, so delivering a much more frictionless user login experience, as well as strong authentication or two-factor authentication mechanisms like SMS and OTP. We've also added a no-code UI branding localization. So under the old version of Cognito, your login page might have looked something like this. I mean, it's perfectly functional. It does the job. But with this new rebranding model, you can actually configure your login page to look something a little bit more like this through a pure low-code model. And I think you agree that's definitely going to compel you to buy more chocolate, if nothing else. And the last feature, which has been a feature in Cognito for some time, but has been tucked away within the advanced security features tier, which has been a lot more expensive, is now available in the Essentials tier. And I should have mentioned the Essentials tier pricing is 0.015, well, it's 10,000 MAUs free tier, and then 0.015 bucks per MAU after that. The advanced security tier is a lot more expensive. So we're seeing access token customization come down into a much more price competitive tier. And why is that relevant to authorization? Well, access token customization enables you to, as the name suggests, customize your access token to include attributes from the user. So now I can customize my access token so that it includes these additional custom attributes, clinic ID and type. And why is that relevant to authorization? Because you can now call the isAuthorizedWithToken API on AVP, and AVP will unpack this customized access token, pull those attributes out of the token, and use them in consideration in your attribute-based condition on your policy. So you can write a policy that combines group membership incognito with custom attributes, hence the combination of role-based and attribute-based access control. So as the PM for verified permissions, I'm particularly excited about that new tier incognito. So in summary, what have we learned? That authorization and authentication are separate. I think we all knew that, but they require separate consideration and separate flows, and in many cases, separate products to achieve those flows appropriately. That building your own permissions management system is, colloquially, a bad idea. It's difficult to scale. It's easy to make mistakes. And as your application gets more complex and your rules get more complex, you end up investing an increasing amount of time in managing something that you should be able to offload to an out-of-the-box solution like verified permissions and CEDAR. And that you can learn from others, and we've seen two great examples showcased on stage today. Considering the integration model, how does your application interface into verified permissions? Where is your policy enforcement point? Where are your policy information points? Where are you gathering the information, calling out to AVP, getting a decision, and then enforcing it? And thinking about your policy design. In both cases, we followed a pattern here of what we call a constrained roles pattern, where your permission is based on a combination of the group that you're in, aka your role, and then some attribute-based conditions. So I'll close just by putting up these QR codes if you want to follow up and learn more about both of these products, CEDAR and AVP. There's a YouTube channel where we post a load of videos on verified permissions. In particular, there's a video that talks about using verified permissions with Cognito. There's a video on migrating to Amazon Cognito. And there's also a whole microsite dedicated to the CEDAR policy language called cedarpolicy.com, where you can learn about how to write CEDAR policies, and there's a little kind of playground you can test those policies. So it only remains for me to say thank you so much for your time, and I really hope you enjoy the rest of reInvent. Bye.